If A, B, C, and D add up to 2001 and B plus D is 2002, what is the value of A minus B plus C minus D? A plus B plus C plus D is 2001. And B plus D is 2002. So we can plug in that there. So separate the A plus C and separate the B plus D like that in the original equation, this one. And since B plus D is 2002, we substitute that in, and then we can solve for what is A plus C. And that will be, looks to me like -1. Okay, so then now let's see what is it that they're asking. They're asking for that. So that is A minus B plus C minus D. If we rearrange it a little bit, it's really just A plus C minus B plus D. Correct? Well, A plus C we know is -1. B plus D, that actually has been given to you in the question, is 2002. And that's it. -1 minus 2002 is minus 2003. Dad dreamed that he put $1 on the first square, $2 on the second, $4 on the third, and so on, doubling the amount each time. It cost $65,535 to cover all of the squares. How many squares were in Dad's dream? So we have the situation, $1 on the first square, and then 2, and then 4, and then doubling it, right? 8, 16, and 32, and so on. You guys get the point. But these are really just powers of 2. This is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on, 2 to the power of 4, 2 to the power of 5. You guys get the point. Now, this is an infinite series, and there's a formula. The sum, see, they're saying to cover all the squares. So they have added all the amounts. So that sum, in the general terms, is A times 1 minus r to the power of n over 1 minus r. Now, even though it goes on forever, for him, he's going to stop at a certain point. Now, what that point is, that I don't know. So even though it is an infinite series, for him it'll be finite, meaning it will stop at a certain point. That's why you're using this formula. The formula for the infinite one is a over 1 minus r, but that's not what we're going to use. We're going to use this one. Okay, so let's see. Let's figure it out. So Sn they gave me, that's the 65,535. A is the first term. So this is my first term, so that's 1. And then 1 minus r. R is a common ratio. So the ratio is really just the second term over the first term. So the ratio is the second term over the first term. And the ratio should be the same. So this is 2. But if I used, say, the third term over the second term, that should also give me the ratio. So that's 4 over 2. And again, it's giving me 2. So I verified that for sure that the ratio in this question is 2. So that's what goes there. And then n, well, that's what we have to figure out. So I'll just keep that in there. And then 1 minus 2 since r was 2. So that's pretty much the formula. So let's see. This looks, well, that side doesn't change. That's just going to be the 65,535. And this is 1 minus 2 to the n all over -1. Okay? So that just means you're going to reverse it, 2 to the n minus 1 like that when you divide through by -1. And then that side doesn't change the same. Doesn't change. And then when you add 1, you get 65536 is 2 to the power of n. And this is actually 2 to the power of 16. So therefore, 16 is equal to n. Well, how many squares were in Dad's dream? The answer is 16. What percent of the first 1 million positive integers are perfect squares? So we have 1, the first number, and then all the way till 1 million. And they're saying how many of them are perfect squares. All right, well, first of all, let's talk about some of the perfect squares. Well, the first one would be 1 squared, 2 squared, 3 squared, like that. And then eventually you'll get to something squared. But 1 million is 1,000 squared. That's pretty easy to figure out. So that means we're going 1, 2, 3, all the way to 1,000. So there's 1,000 perfect squares from 1 to 1 million. But that's not what they're asking. They're asking a percentage. So there's 1,000, and the total numbers were 1 million. So this is basically the percentage. And that, in terms of a percent, is 0.1%. A square is inscribed in a quarter circle region as shown so that one vertex of the square lies on an arc of the quarter circle and two sides of the square lie on the radii. If the area of the quarter circle is 4 pi, what is the area of the square? Let's draw this diagram here and let's see. Okay, so the first thing I'll do is just draw a line that's a diagonal, and let's see what I can do here. It's a square, so the sides, just call it x. And the radii, did they tell us? No, they just give us the area of the quarter circle. Okay, well, the area of a circle is pi r squared, so the area of a quarter circle would be pi r squared divided by 4. And they're saying that is equal to 4 pi. Okay, so that will allow me to figure out the radius. So this is going to be pi r squared is 16 pi. And then drop the pi's, r squared is 16, so r is 4. So that means this diagonal is 4. And since that's a square, that's a right angle. And we can easily figure out the side, the length of the side. So x squared plus x squared using Pythagoras would be 4 squared. So 2x squared would be 16. And therefore x squared is 8. And this area of the square is x squared. Well, x squared is 8. So there we go. 8 is the area of the square. A sequence of numbers is arithmetic if the difference between successive terms is a constant. In a sequence of integers s, the first term is 81, one term is 144, the last term is 256, and no terms are consecutive integers. If s is arithmetic, how many terms does s have? So if it's an arithmetic sequence, it would be of the form a plus d, a plus 2d, a plus 3d, and so on, right? So are we told anything here? We're just told first term is 81. Okay. Second term, they just say one term is 144 and last term is 256. Okay, I got it. So they don't tell me much. Yeah, they don't tell me much. All right. We have to do a little bit of maybe some experimentation since we're given with such limited information. Okay, so the first term is 81, so that's pretty much the only thing we know for sure. And then some term, I don't know what it is, so I'll just call it KD. I don't know what the K is. That's 144. And then the last term, so for example, a plus 4d, this is 1, 2, 3, 4, 5. So if the number of terms is n, this guy would be n minus 1, correct? So in this case, there's 5, like I wrote 5. And because that's 4, it would be represented by n minus 1. So n minus 1d is the last term. And that they're saying is 256. Okay. So this is the only thing we have to work with. So that obviously is going to involve experimentation, because 1, 2, 3, 4 variables and only 3 equations, so we can't solve it, but we could figure it out. Okay, so first let's go with this first one. 81, a is 81, so that's 81 plus kd is 144. So kd would be 144 minus 36, which is what, 63. And then that's about as far as we can go, but I'll just break it up. 63 is what, 9 times 7? We'll just leave it at that. Because obviously it's 2 numbers, so I'm trying to see what 2 numbers it could be. Okay, and that's about as far as I can go with that one. Now let's go for this next one. That, again, A is 81 plus n minus 1d is 256. And n minus 1d, 256 minus 81 is what, 175. And then again, n minus 1d. Can I break up 175? Let's see, 25 times 7? Yeah, 25 times 7. Okay, that's actually good because, see, this d always has to be the same, right? So this d could be 7. See, there's a d here, and that's a 7. And then, therefore, this k is the 9. And then this n minus 1 is the 25. And that would work. Okay, perfect. So that means n is 26. And that's what they're asking. How many terms? The number of terms is 26. What are both primes p greater than 0 for which 1 over p has a purely periodic decimal expansion with a period 5 digits long? Note 1 over 37 equals 0.027, starts to repeat immediately, so it's purely periodic. Its period is 3 digits long. 1 over p, they're saying, is some decimal that's 5 digits in terms of its period. So let's just call it A, B, C, D, and E, right? 1, 2, 3, 4, 5. And we put that big line to show that it keeps repeating. It would be A, B, C, D, E, A, B, C, D, E, and so on. So what I will do is I will multiply this, both sides, by 100,000. And if I do 1 over p and then 100,000 over here, times that 0.A, B, C, D, E, repeat like that. When I do, this side becomes, let's think about this. What does it become? 100,000 over p? Yeah, not much difference there. But this side, of course, becomes A, B, C, D, E, and then the A, B, C, D, E, of course, just keeps on repeating. Now what we can do is we can take this guy and subtract them. So it would be 2 subtract 1. And what that does is it just makes that A, B, C, D, E, because then that entire decimal part vanishes. And that's really the whole purpose of this multiplication by 100,000. The other side, what happens? Well, let's just write it out. It would be 100,000 over p minus 1 over p. So that looks like 99999 over p is A, B, C, D, E. Okay, so that's pretty much the goal there. Okay, let's cross multiply 9999, and then on the other side it'd be p times that A, B, C, D, E. And then the 99999, that we need to break up because they're talking about primes, right? Yeah. So, well, this 1 over p, that p is a prime. So we have to break this up into its prime factors. And when you do, you would get 9 times 1, 1, 1, 1, 1. Okay, that's pretty obvious. But then that 9 would be 3 to the power of 2. And then this guy breaks up into 41 and 271. Those are the prime numbers. And of course, this side just remains the same. A, B, C, D, E times P. Okay. So what? Okay. So we've got P on this side and this A, B, C, D. So something in here is the P and something, all the other stuff is A, B, C, D, E. So, okay, well, what could it be the P? The P could either be 3. It can't be 9 because 9 is not a prime. It could be either 41 or it could be 271. And those are the possibilities. I think that's the only 3. So let's see what happens. Let's try and figure out what is 1 over P. 1 over 3. If it's P is 3, then it'd be 1 over 3, and that's 0.3 repeat. So that has a period of 1. So that is not our correct answer. Okay, no problem. Let's try P being 41. If it's 1 over 41, that is 0.02439 repeat. So that has a period of 5, and that is what we want. We want a period of 5. So 41 is one of the right answers. And then, of course, the only other choice we have is the 271. And when you do that, that's 0.00369 repeat. And that, of course, also has a period of 5. So those two work. And therefore, P is either 41 or 271.